That's a joint experiment between National Center for Asphalt Technology at Auburn University and the Minnesota Road Research Project, which is part of Minnesota DOT. And it's great that I'm on after this last panel because I'm their data guy. You know, the data that we're generating from this experiment is fueling the decision tree process to give people the performance data that they need in order to determine what is the best treatment or combination of treatments to provide the lowest possible life cycle cost. So I get to do the fun part of this, and I'm very excited to be here today to provide you with an update on the research. And of course, I've been at the test track now for 19 years, and we grew into pavement preservation research beginning in 2012 in order to meet at that time the growing research need that our state DOT clients at that time. So we have some preservation sections on the track, and then we have sections off the track, low traffic and high traffic, and then we also have low traffic and high traffic up in Minnesota to serve the needs of our northern partners, of your northern partners, because as you can see on this graphic, most of the states that are in the Southeast Partnership are funding partners at the NCAT Pavement Test Track in the Minnesota Partnership, and we're proud of the Minnesota Partnership because we've grown from 8 states when we started the NCAT Pavement Test Track back in 1998, finishing the first track in 2000, to we're at 20 states now, and I'm pretty confident that number is going to increase to 21, and it could actually increase up to about half the states in the country. So we're really excited about getting more states involved, because when more states get involved, it helps us to keep the cost down for the research to the states that are involved in it, and it creates a little bit of resources so we can do some new things for you and provide you with that life cycle cost data. The reason why we need to do this is because, you know, the other reason I'm excited to be here is because I started my career in pavement management, so I feel like I'm among my brothers and sisters here in this room, and I remember in the mid-'80s we were drawing curves like this using live data from our pavement management system, a life cycle curve of a pavement where we want to stay high in that curve to do preservation as opposed to spending more money as we get farther down the curve. And when you know, there's some MPOs here. When you're using the PCI scale, you superimpose that on that curve. Of course, as we go farther down, we're spending more money. So we want to stay in the high part of that curve. I told Judy, we were in Connecticut last week, and I was doing training recently for New Mexico, and I'd be curious to talk to those of you here who may have done this, but they've actually gone in and put dollars to the various treatments. They've pulled dollars out of their budgeting system, and their y-axis scale on this is about $900,000 per lane mile. So you go from zero at the top of that curve as you go all the way down to reconstruction at the very bottom. That's about $900,000, and it's more or less a linear scale. So I'm gonna generate some new graphics for that. But what we really want to do is, instead of just doing a worse first as you get down, as you let a pavement deteriorate, we want to use a combination of preservation treatments to try to stay high in that curve and minimize the life cycle cost of that pavement. And the reason why we need to do this is, you know, you can get feedback from your pavement management system, and it might tell you that treatment A might last between 3 years and 10 years. Well, when you have to make an economic decision, what many of you are doing is just using the average number within that range. And we know that's not right, because when you do a preservation treatment on a good road, you get a really long, you expect to have a really long life, and when you do a preservation treatment on a bad road, you should have a really short life. And it's the relationship between the short life and the long life as a function of pretreatment condition. That's what we're working to quantify in this, what we call our preservation group experiment, which is half of the Minnesota Partnership. Well, in order to do this, we set out to have good materials, good designs, and good placement quality. And a lot of people participated in this. We had material suppliers donating really good quality aggregate, good emulsions. Mike Hemsley, I talked to him out in the hallway, and it was all in the middle of working on all of our rate designs and our mix designs for the things that we placed in this experiment. And then Tim Harwood is here with Vance Brothers, and they work really hard to put a good quality product down. And we had our inspection team at all the southern locations and the northern locations. So the unique thing about this experiment, if you haven't heard us talk about it before, is we used regionally appropriate materials, and we had the exact same contract team for the emulsion treatments and for the thin lay treatments, and the exact same inspection team at the low traffic and high traffic down south and the low traffic and high traffic up north. So by controlling all those things that can really confound the outcome, we were able to relate the performance of the different treatments to pre-treatment condition. So when we got out and we started building these sections, our designs were verified using actual on-site materials. So we shipped source materials to Paragon, who did our mix designs for us, and then when we had materials on the ground at the job, we did design verifications with those materials. We calibrated all of our rates and verified everything at the time that the sections were placed. And prior to 2012, a lot of this work I had not been involved in the past, so it was a great learning opportunity for me to be able to do this. Adriana Vargas is here. She's the PI on this experiment. I'm just kind of the mouthpiece for it today. But what she brought to the table was looking at our data through a MAP 21-like lens. So our focus in the life extending and the condition improving benefits is cracking, rutting, and roughness. That's our focus. But we're also collecting a lot of non-MAP 21 data. A good example of the non-MAP 21 data is friction. We measure friction every week with all of our experiments, and that can be a regionally very important thing because some of the aggregates that we have in the southeast. And as I said, we're relating the performance of all these treatments back to varying levels of pretreatment condition. The exciting thing about my role in the experiment in this research cycle is we really have a big focus on implementation. You know, drawing these curves and developing these relationships is really important, but what we really need to do is get it into the hands of the people that are making the programming decisions. And part of my job over the next 3 years is to do everything we can in order to support that. So as I said, we have emulsion treatments in the experiment and we have plant mix treatments in the experiment. On the emulsion side, fog seals with and without rejuvenators, chip seals, conventional with fiber, and then as scrub seals. We've got microsurface, all different kinds of microsurfaces with highly polymer modified binder and with and without fibers and multiple single layers and multiple layers. And then we got cape seals, microsurface on top of conventional chips, scrub seals, and then also fiber mat chip seals. On the plant mix side, the primary focus on the plant mix side is 4.75 nominal maximum aggregate size thin lay mixes that really are close cousins to the Mississippi thin lay that we placed on the NCAT pavement test track back in 2003. That mix, even though it was a 500,000 easel mix design, something that we were looking at for Mississippi for a county road, type of an application. Now it's been down for 50 million easels with no sign that it's going to change. It's in excellent condition, and it's just a 3/4 inch thin lay. So that was our starting point for our thin lay mixes in the preservation experiment. And the mixes that we placed down south are very, very similar to the Mississippi mix. And then the northern mixes, we used their local materials to simulate it as best we could. We've got virgin versions of that mix, 50% wrap, 5% shingles, and then through a balanced mix design process, we settled in on 11% fine fractionated wrap and 3% shingles for our high traffic version of those mixes. We've also got our thin lays on top of 100% wrap cold recycle mix, and that's with central plant and in place using both foam and emulsion. We've got what Mark Woods is in the back of the room, what Mark and Clay called an HMA cape seal back when we added them to the experiment. And these are 3/4 inch thin lays directly on top of all different types of chip seals, and they've worked extremely well every time we've evaluated them. And then finally, for some of our southern states that were having performance issues with OGFCs, with thin OGFCs, we added OGFCs with all different types of tack materials and different rates to our high traffic test sections. So as I stand here today, The test sections that started it all for us on Lee Road 159, which, as you can see in this picture, is a dead-end access road to a quarry and an asphalt plant. These treatments have been down for 6 years because there's empty trucks running in to this road, into the quarry and the asphalt plant, and loaded trucks running out. About 70,000 easels inbound, and we're close to 900,000 easels on the outbound side now. And these sections, after 6 years, all of them are performing well. We've got a good range of performance now. We have some amount of reflected cracking in every test section on Lee Road 159. It's just different levels of reflection, which is what you would expect. So we took what we learned on Lee Road 159 as a low traffic installation, and Alabama DOT gave us permission to install the same treatments in an expanded experiment out on US 280, and 4.5 miles on US 280, about 5 miles from the test track. We were able to stage everything from the test track, do all of our setup and calibration and storage and everything at the track, and mobilize out to US 280. And since we put those out there, we're actually approaching 6 million vehicles in the westbound truck lane of US 280, and we're over 1.5 million easels. And those have been down now. This summer will be 3 years. Again, with different levels of good performance, and we've got a lot of reflective cracking that's coming back through now in our treatments that we've installed on 280, and we're mapping those on a weekly basis, just like we are on our test track. So what we've done is umbrellaed these off-track preservation sections underneath our testing activities there at the NCAT pavement test track, but where we run a fleet of heavy triple trains to compress traffic that do about 100,000 easels a week on the test track. We're just getting the natural traffic flow out there on these test sections, but we have a good system in place to document how many vehicles we experience and how many easels we experience. Well, also in the 2015 research cycle, that's when we engaged in this partnership with the Minnesota Road Research Project. So Minnesota DOT in the previous research cycle was a subcontractor for us. In the current research cycle, 2018, we actually are going to have a two-way relationship with Minnesota. In the preservation experiment, Minnesota is the lead agency, and we're going to be their subcontractor, or we are their subcontractor. And then for the cracking group experiment, which is the other half of the partnership, NCAT, Alabama DOT is the host agency, NCAT is the lead, and Minnesota DOT is going to continue to be our subcontractor. We've got select preservation treatments on the low volume loop there at the MNRoad facility, which is just to the northwest of Minneapolis. But the focus of the preservation research is their version of County Road 8, County State Aid Highway 8 is the low traffic roadway, and then US 169 is the high traffic roadway. And those are about 45 minutes north of the main MNRoad facility, but they've umbrellaed these test sections off-track test sections the same way that we have. And if you look at how they lay out, they're just south of a little community called Malacca, Minnesota, in a little town called Pease. There's an intersection between US 169 and County Road 8, and that's where these two projects connect together. The traffic levels on these two roads are virtually identical to the traffic levels on Lee Road 159 and US 280. So Minnesota did a great job of picking these test sections, and as you might imagine, this past winter, they had air temperatures up there where our test sections are located of minus 34 degrees Fahrenheit. Bitter cold weather up there. So where we're in the Gulf Southeast and our focus is hot weather performance, the focus up there is thermal cracking. So there's thermal cracks up there. When the pavements shrink in the wintertime, you could put your foot in some of these thermal cracks. They're so wide when the pavement fully contracts. So we knew we were going to get reflection of these thermal cracks. The big question was how quickly are they going to reflect, and then what's going to be the severity level of the reflection when they occur. So every test section that we installed in Minnesota on the preservation side has some amount of reflected thermal cracking in it. The interesting thing about it is, for those of you who've had a chance to visit the test sections, and we alternate our 6-month sponsor meetings between NCAT and MNRoad, so many of y'all have had a chance to walk the sections and to take a look at them, especially on County Road 8. But the interesting thing is that the trends, the differences in test sections that we've observed in the South, I'd say the same types of trends and relationships we're seeing develop up north. So it's a very, very interesting thing, because we're seeing similar results. And a good example, y'all have heard me talk about it a lot, crack sealing. Crack sealing is a standalone treatment, and crack sealing in combination with other treatments, it does a really good job of preventing the recurrence or the reflection of the cracking that is there in that test section. And that's a standalone microsurface on the left, and then microsurface where we blow and band crack sealed it on the right. So it does have a significant effect on the cracking that develops in these sections. Of course, the objective of the study is to draw these curves as they develop. So this is information that's really hot off the presses, and again, credit to Adriana. She's done a great job approaching the data from a MAP 21 point of view. I'm really excited about this because on the front end of the research back in 2010, 2011, I worked with FP2 to develop this methodology in the hope that these would be the curves that we would see develop. But as a researcher, you don't ever know what you're really going to see. You know, you have a concept of what it should look like, but whether or not it actually shows up is all about the data. You know, we're data people. And it's very encouraging to me. I'm extremely excited that the curves that Adriana is developing based on the performance that we measure on 159 and 280 in the northern test sections, it actually looks like we would expect it to look. So these curves represent the MAP 21 version of good, fair, and poor, where the good curve is green and fair is yellow and poor is red. The solid line is the cracking that we're measuring in these test sections, and then the dashed lines are what would be in the sections based on the control sections if we had not done anything to them. So in other words, the x-axis shift is the life extending benefit, and then the y-axis shift between those curves is the condition improving benefit. So these are the curves that you need to drop into your decision tree. Instead of just using average values, you can pull out pretreatment condition from your pavement management system, and then you can decide which one of these improvements you need to plug into your economic analysis when you're doing your treatment comparisons. The other way to look at the data is to say, you know, if you're, like James Williams said, if you're in a position where you're managing the decline of your network, you can look at the treatments and you can say, okay, based on these conditions or my pretreatment condition, how long is this treatment or this treatment combination going to keep me out of the poor range? And then you can use that period of time to program into your decision tree. Now the data that I'm showing right here is a chip seal with crack sealing. So I'm just going to very quickly step through some of the treatments and the treatment combinations that we have. This is all data from Lee Road 159 because we've got the most time behind us on Lee Road 159, but Adriana is monitoring the data from all 4 test locations using the same methodology. So this is single layer microsurfacing, and as you can see, you know, you get a pretty big dip in the curve. No big surprise there. If you put microsurfacing down on a pavement that's got a lot of cracking in it, the cracking shows back up really quickly. That's what we know is going to happen, but this is hard data to tell us that that's what happens. The interesting thing about this is the good and the fair with microsurface is kind of tracking along in a very similar way. So that's a pretty significant finding in itself, I think. So this is a double layer microsurface. This is a big surprise because the double layer micro, it's surprising, but intuitively it kind of makes sense. The more thickness that you get in this case with 2 passes of microsurface, it does a really good job of preventing that reflective cracking that you saw in the previous slide. So again, this is a way you can plug that improvement into an economic analysis. This is a virgin thin lay and this is just that Mississippi mix that I was telling you all about. It's just a screening and sand mix. It's got it's 70% limestone screenings, 30% hard sand. It's about 6% asphalt content, and this is a virgin mix with PG 6722 neat asphalt. It's in excellent condition. The good, the fair, and the poor are all tracking pretty close to each other after 5.5 years worth of data. And this is data that I shared with Alabama County Engineers Association last week in Orange Beach after the Connecticut meeting. When you take that same virgin mix and you put 5% shingles in it, post-consumer shingles in it, look at what happens to the performance curve in the areas that were pre-treatment poor. You get to a certain point in time and it just takes a nosedive and it starts to deteriorate pretty rapidly. And intuitively we know this. We've seen this happen on many of our county roads, but again, this puts some hard data to it. So this is a virgin aggregate blend with nothing but 5% post-consumer shingles in it that gives you about a 19% aged binder replacement. So about 80% of the binder that's in that mix is virgin binder, and the other 21% is coming from post-consumer shingles. And this is one of our big success stories. This is a virgin thin lay on top of a 100% wrap cold recycle mix. This was done in a central plant with foam. Again, this is from Lee Road 159. And Lee Road 159 is 5.5 inches total thickness of the asphalt layers. And in one section, we milled all that out and we put 100% wrap foam cold recycle mix in, and then we put a 3/4 inch thin lay on top of it. And we did that not knowing exactly what was going to happen, because we got all this quarry truck traffic going in and out, and there were people that were telling us, yeah, it's good that you're doing this because it's going to generate some good performance data, but it's going to fail. Be prepared because it's going to fail pretty rapidly. Well, it's arguably the best performing test section we have on Lee Road 159. And because it did so well, when we expanded the experiment under high traffic out on US 280, we grew that combination of treatments, and we did central planting in place. We did it with both foam and emulsion. And then we put a 1 inch thin lay on top of it. And that 1 inch thin lay was the 11% fine fractionated wrap and 3% post-consumer shingles that I talked about earlier. And we iterated to that combination through a balanced mix design process, running mix through the plant with different percentages of recycle in it and rushing samples back over to the NCAT lab to do rutting testing with an asphalt pavement analyzer and crack testing. In our case, we did it with a Texas overlay tester. And there's no rutting and there's no significant cracking in that test in any of these 4 test sections on US 280. So on Lee Road 159 and on US 280, the cold recycle mix has been a big success story. And these are with the thin lay mixes that we ran through the balanced mix design process. Now this mix we put down at about, on Lee Road 159 was about 80 pounds, and then we did it with a 1 inch target thickness. When we did it on US 280, our contractor is East Alabama Paving. Well, one of the test sections we're doing for Alabama on the track in this cycle that we're placing this summer is they wanted us to do a 50-pound thin lay, come up with a design, with a specification and a design that could be used to place a really, really thin lay mix as a preservation treatment. And East Alabama Paving has been our contractor for the last 5 cycles. And they called us a few weeks ago and said, hey, we've got a city street that we're doing that's an old concrete pavement that had an overlay done on it. It's got really ugly cracking. It's a very rough road. It's in really bad shape. They don't have enough money to do any crack sealing or any kind of repairs. What would you recommend that we do to this? So I thought, well, that's a perfect application for our sand screening thin lays. That the thin lay mixes, because the material is so fine, it might be that in the spalled cracking that's there, maybe that mix will compact into those cracks and seal them up. And if you run it with a relatively rich asphalt content, it might be that you can prevent the reflection of that cracking and then put an overlay on it. So they took the money that the city had, and they were actually able to fit that into the job and keep that on budget. And I wanted to show you this picture because that's a core that they cut off of one of these old transverse joints where the cracking had reflected, and you can see that screening mix and how it actually did compact down into that reflected joint, that deteriorated joint. And it turned out so nice that the contractor called us and they said, you said you were interested in proposing this mix to Alabama for this 50-pound thin lay. You need to come out here and take a look at it and make some measurements. So we did, and they actually did place it at 50 pounds per square yard. And we ran our profiler on it when we went out to look at it. And I'm shooting from the hip, but I want to say we got an average roughness of 35 inches per mile with a 50-pound thin lay on top of that cracking. and then they came back and put, I think it was a 1-inch surface mix on top of the thin lay. So they put that sand screening mix in there to prevent the reflective cracking, and then they put a surface mix on top of it, and we measured in the mid-30s for roughness on top of that 50-pound mix and on top of the surface mix. So we think that's a really good approach and has a lot of capability, and we're going to work with Alabama to potentially put that same mix on the track for them in this research cycle under accelerated traffic. The other half of the Minnesota partnership is what we call the cracking group experiment. Those of you who have been associated with the project for some time, you've heard us talk a lot about this. To me, the preservation and the cracking group, I was talking to John Wilcoxon about this during the break previously, they go hand in hand, because that thin lay mix is going to perform well when it's got the right amount of binder in it. You know, when you're not trying to run it dry, when you're not loading it up with reclaimed and recycled material that are potentially aged too much and make the mix brittle. That mix can't be brittle, or it's going to crack. It's going to have some durability problems when you put it down. So for that reason, you know, to me, the preservation group and the cracking group go hand in hand as far as the thin lays are concerned. The objective of the cracking group experiment is we put a whole set of test sections on the track. We put a whole set of test sections at the main MNRoad facility, and then we sampled a bunch of mix at the time we built the sections. We put together a lot of samples when the mix designs were being done. Half of them are aged, half of them are unaged, and we're running a battery of tests to see which tests that you have available, that your materials people have in your departments, which tests do the best job of comparing to the performance that we actually observe on the NCAT track and at the MNRoad facility when your focus is thermal cracking. And the preliminary findings from this study are really interesting, and I'm going to share with you some IFIT numbers. If you don't know anything about materials, the IFIT test is the Illinois Flexibility Index test, and that's just a fancy way to say we're going to evaluate the fracture energy of these mixes. So instead of just testing a sample and taking a peak load off of it, you're actually looking at the entire load curve, and the area under the load curve is fracture energy. So it's just sort of a brittleness assessment of the mixes. If you look at the data from the track, and this is, you know, our focus at the NCAT track is fatigue cracking, and that dashed line is what Illinois says is a good mix. Above that, high bars are better, more area under the curve, a more ductile curve. The good news is that the 4 sections that cracked first on the NCAT track are the 4 sections that the IFIT predicted would crack first. And the problem with the IFIT test is it's like a special sample preparation. And my view of balanced mix design is we should start with mix production, and we need to be able to test samples during production to make sure we keep bad mix off of your projects, bad mix off the roadway. And in sampling and testing during production, we need to turn results around. As our target for turning results around should be how quickly do we currently get volumetric results. And that's hard to do. That's probably impossible to do, but we need to be as close to that as we can be, because if I'm a contractor and I run mix this morning, I need to know by this afternoon whether I'm in penalty or bonus or whether I meet specification or what. 2 weeks after I run that mix, that doesn't do me any good. I need to know whether I need to make a correction or not. So this is kind of the analysis methodology of fracture energy. Again, that's the load curve, and that can be testing a sample in many different ways. In this case, it's called an SCB sample, so it's a pill that you've cut in half and notched, and then you're looking at the area under the curve and in the post-peak slope. And the reason why I'm showing you that, I'm not trying to blind anybody with a fancy test result. What I wanted to show you is that test, the flexibility index test, you have to make a pill, and you have to cut it and dry it and get it in the jig in the right temperature, and then you test it in a Marshall press and you collect the data. You subject it to that analysis. Well, our thinking again on this is you need to be able to turn these results around really quickly. So we took TSR data, which you're already running tensile strength ratio tests, indirect tension testing in your contractor's lab. Most of you are every 10,000 tons or every 20,000 tons or at some interval. And we did the same kind of fracture energy analysis with data that you're already collecting on your projects, and the results correlate beautifully. So you can do a fracture energy analysis on a test that your contractors are already running, but unlike TSR testing where you have to condition samples overnight, you can make a pill, compact it to height instead of gyrations, take that pill, cool it down, put it in a Marshall press, break it, capture the data, look at the fracture energy of that test result, and then you can determine a pass or fail. You can see a brittle mix. So if you approve a mix design because you think because it performs well and has good fracture energy, and then when you're producing it, maybe it produces a little bit dry, you'll catch that when you do this height compacted half of a TSR type of analysis. And this is the kind of thing you can turn that number around in 3 or 4 hours on a job and get same day data. So we're doing more work with TSR testing or with dry TSR testing for fracture energy analysis. We're going to expand that part of the research. My hope is that this pans out because, and this applies to the thin lays, we got to get good quality with these thin lays, but our philosophy with all the preservation treatments is it's all about having good materials, good design, good construction quality. So when we did the microsurfaces up in Minnesota, we validated a microsurface quality control test procedure where it gave us a gradation sample to test, and it gave us residual binder content with a micro. Everything we do needs to be a good design, needs to have good construction quality so that these curves have as much meaning as possible. So we're really excited about the fracture energy analysis. I also wanted to show from US 280, somebody commented to me about US 280, and those of you who were at the Montgomery meeting last year, we did tours out there. You can see a lot of reflected cracking out on US 280. One of the things that I think we pointed out during the tours last year is we've got one area out there where there's 3 Cape seals. There's microsurface on top of a conventional chip, a fiber mat chip seal, and a scrub seal. And it's hard to see on this slide, but when you go from the conventional chip to the fiber mat chip seal and to the scrub seal, there's a huge difference in the reflected cracking between those 3 sections. And that's the kind of information that this experiment captures, the benefit that you get from the different treatment combinations, and then therefore the life cycle payback that you get from that. And again, US 280 has got over 1.5 million easels on it. So to kind of summarize all that, again, we've got good performance with everything that we've done, just different levels of reflected distresses to this point in time. So it shows the value of good materials, good designs, good construction and inspection. We are capturing the life extending benefit, the x-axis shift, and the condition improving benefit, which is the y-axis shift. And that data is developing over time. Adriana is doing a great job with that analysis methodology. And again, I'm excited about that because of my background in pavement management and what that means in the decision tree process for all of y'all. We're measuring the reduction in subgrade moisture content still. We've been doing that actually since 2012, so we've actually got 6 years worth of data from Lee Road 159, and that's a gold mine of information in itself. We're seeing similar trends between all the test sections, low traffic, high traffic, in the southern and the northern sections. And we're actually in the middle of the planning process to add cold recycle sections up north. That's the one thing that we don't have in the northern sections. And so we're working with Minnesota DOT right now to add cold recycle. We want to do central plant and in place, and also FDR. And FDR is kind of, outside the scope of pavement preservation, but it's one of those tools in the toolbox. And those of you who are from the smaller agencies, that's a big important thing to counties right now, for example. Doing FDR to try to salvage what are really failed pavement structures. And I hope that we can also add hot in-place recycling to the northern sections, but we're going to have to see how that works out. We anticipate collecting data from these sections for a very long period of time, and we want to work actively with you to help you to implement the data that we're pulling off of all of these test sections. Deployment is a big part of what we're doing, and I would love to see us get to half the states in the country supporting the research, because, as I said, it makes it more cost effective for everybody else. Well, we hosted a conference back in March, and we went into a whole lot more detail than I have time to in 30 minutes here. And the reason why I'm showing this is if you go to ncat.us/pavetrack, the agenda for the conference will pop up, and it's got hot links to all the individual presentations that were made. So if you want to go to that and pull up those resources, the focus of the second day of the conference, March the 28th, was pavement preservation, and you can pull all those presentations up and investigate that more for yourself. But if there's anything that I can do to follow up with you directly, again, we really want to actively support deployment and implementation. So if I can help y'all in any way, please don't hesitate to let me know.
Concerning the study that you conducted, or your staff conducted, in terms of life expanding and condition improving for the preservation treatments, have you looked into the life cycle impact also of extending the life of the pavement in general?
We're stopping short of doing economic analysis, but the purpose of these curves is to quantify the benefits that we get from the different preservation treatments. We've had a lot of discussion about whether or not we should put money in that and do an economic analysis, and what the group decided, the group of funding states, was let's let the local markets put the dollars in there. If we just provide these curves, then within the local markets, depending on how much competition there is between the treatments, that's where the economy needs to come from. That's not something that we need to get involved in, which I prefer that. I'd prefer just to stick to the data part of it.
Are you looking at one of the things? I'm from Nevada, and at UNR we've done some studies on the benefit of preventive maintenance treatments, and one of the mechanisms that shows up apparently is how it retards the aging of the underlying pavement structure. Mm-hmm. And I remember you guys were kind of looking at that rate of oxidation on some of that stuff. Mm-hmm. How is that going? And of course that relates to the initial condition as well.
That's something that's a good question, and that's something that Ingevity really has taken the lead on. They funded the testing that we did with that, and we do have samples, destructive sampling that we did selectively from test sections, is what this gentleman is asking about, and we do have some oxidation data that we think is going to be a good product of the research, but it's not something that I could really comment on today. So we do have some data to drive that process, and we've also got one test section on the track that is a true preservation section, where it didn't have any cracking in it, and half of that section we put a microsurface on, and then the other half of it we just left it the original HMA buildup, and now there's a really significant difference in the cracking that developed without the microsurface compared to the one that we put the micro on. And my hope is that we can leave that section in place on the track and continue to collect data from it, and that the focus of that is going to be protecting from oxidation of that surface layer.
Well, since you started the preservation, what's been the biggest surprise to you of this whole thing?
I think the biggest surprise to the state agencies, and I guess I would put myself in the same category, is the good performance that we've seen from so many treatments and so many treatment combinations. Lee Road 159 that's one of those roads where you would not go out there and say, well, I'm going to put a micro on this road, or I'm going to put a chip seal on it, or I'm going to put a thin lay on it. I mean, there was a lot of, you saw the road, there was a lot of really aggressive fatigue cracking in that outbound lane and that outside wheel path, and we've seen really good performance. Those treatments have been down for 6 years, and the vast majority of the sections really are in good shape. We've got reflective cracking that we're mapping, but it just kind of jumps out at you when you've got good materials, good designs, and good construction quality. You can have an outstanding outcome. So we, where we're taught some of these things are really lightweight treatments and don't have too high of expectations from them, you can see good performance from a lot of these treatments, and that's been a very pleasant surprise. And so we want to, as part of implementation and deployment, we really want to help states to work out specifications implement specifications that will achieve the same quality outcome that we've observed in our experiment. And the same thing's true up in Minnesota. Excellent performance in all of our treatments and treatment combinations up there. Thank you all very much, and I'll be around this evening if any of y'all want to chat about this.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.